Morning, Year 9s. Prepared to be amazed. I'm going to talk to you about scientific notation, which is a way of writing very big numbers and very small numbers. Very big numbers like the speed of light. Big numbers like the number of particles in 1 gram of hydrogen, the number of atoms in 1 gram of hydrogen, like distance to the sun. Really, really tiny numbers like the mass of an electron, or the size of a coronavirus particle. Okay, I'm going to start by looking at the speed of light. The speed of light is about 300 million meters per second. Now, scientists have to do calculations with that number. They've got to write all those zeros. Calculations like, I wonder how far light travels in a minute. Well, if it goes that far in a second, then it would go 60 times that far in a minute. And then they'll have to write down an answer. 3 6s are 18, and then there's a big heap of zeros. There's 3, 6, 7, 8, and one over there, that's 9 zeros. 1, 2, 3, and obviously if you get 1 0 wrong, your rocket crashes instead of travelling at the speed of light. That would be meters per minute. And it gets really cumbersome writing all of those numbers in with all the zeros. So there's a shortcut, or a short way of writing them. We start, there's always a decimal point at the end of that number. There's an assumed decimal point at the end of the number. So what we do is we count how many spaces that decimal point goes back until we find a digit like 3, a digit that's not 0. So we roll back here, 1, 2, 3, 4, 5, 6, 7, 8 places, and the decimal point goes there. So it's 3 times 10 to the power of 8, because 8 is how many spaces we moved our decimal point back, how many zeros there are in that number. This number here, 3 times 60, is, let's see, count those decimal places. 1, 2, 3, 4, 5, 6, 7, 8, 9. We could write that as 18 times 10 to the power of 9. But when we're writing in scientific notation, we only have one number in front of the decimal point. So we're going to move that decimal point back one more place. We're going to go 1.8 times 10 to the power of 10. So we put the decimal in here. We start at the end and we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We go to the first number that is not a 0, decimal point goes after it, and all of these spaces that come after that is that number there. Do some examples for you. I don't think I'll do them in yellow. All right, let's write the number 40,000 in scientific notation. So we start here and we count back to the 4. 1, 2, 3, 4 places. So that is 4 times 10 to the power of 4. And just to show you, this is nothing magical. This is real. If this equal sign says that this is the same as this. So you could write 4 times 10 to the power of 4 as 4 times 10, because you know how to do indices, times 10 times 10 times 10. Okay, that's 10 to the power of 4. And if you stick that in your calculator, you're going to get 4 with 1, 2, 3, 4 zeros, which is 40,000. What about this number? 5,826 in scientific notation. So you start at the end, count back 1, 2, 3 till we get to the first number, and the answer is 5. 0.826 times 10 to the power of, we moved the decimal point 3 places. 2,700, we could write, let's start with our digits, 2.7 times 10 to the power of 1, 2, 3. And if you typed in 2.7 times 10 times 10 times 10, you will get this as your answer. Let's look at going back the other way. We will just change colours and go down to this corner. 3.74 times 10 to the power of 4 equals, and we're going to move that decimal point 4 places. 1, 2, another 0, and another 0. So we're going to end up with a decimal point there, four spaces after the 3, 1, 2, 3, 4, 37,400. Another one. 28.36 times 10 to the power of 3. So we move our decimal point 1 space, 2 spaces, and we're going to chuck a 0 in there. So we're going to end up with 28,360. And you're always, with any kind of maths like this, you should always work backwards and say and find out for sure if that does equal this. So if I were to go back, 28.36, I actually wouldn't write it like that, would I? I'd write it as 2.8360 times 10 to the power of 4. So I hope this doesn't confuse you, but 28.36 times 10 to the power of 3 is the same as 2.836 times 10 to the power of 4, because I've moved the decimal point back 1 space to get this, so I've added another space. All right, we've got some questions, and I'm going to talk about small numbers separately.